Okay, so for this lift question, we're going to start by getting ourselves a simplistic diagram that we can work with and that we can add our forces to. So we have our lift being supported. It's being operated by the means of a vertical cable. So we've got a cable coming from the lift, which we know there's going to be tension in. And we know that the lift itself has a mass of M. So the weight acting downwards is going to be mg. And we've got boxes of Q and P inside this lift on top of each other, and we've got a combined mass of those of P and Q. So I'm going to call the masses P and Q, and that's going to give us a combined weight of P plus Q times G acting downwards. So the cable is modelled as being light and inextensible, and we've got air resistance being negligible, and we have been told what the tension is here. We've been told that this is 42 mg over 5, so we can add the tension to our diagram. The cable, so the lift is, and its contents are moving vertically upwards with an acceleration, so my direction of motion is upwards, and I've got an acceleration of 2g over 5. So that's the basic model that we want to work with. We're going to apply Newton's law now to be able to work on finding out what that combined mass of P and Q are. So we've got F equals ma. So my force, if I'm thinking about going upwards, is the 42 mg over 5, which is the tension in the cable, minus the weight of the lift, minus the combined weight of the objects within the lift. And that's going to be equal to the combined mass, which is m plus p plus q, times by the acceleration, which is 2g over 5. So I'm going to simplify this. I'm going to cancel out the g's because they appear in every term, and I'm going to multiply through by 5. So I'm going to get 42m minus 5m minus 5. My combined is P plus Q, so I'm going to leave that unfactorized, unexpanded. That gives me 2m plus 2p plus q. So if I simplify this, I'm going to get 7p plus q equal to 35m, which gives me that combined mass of P and Q as being 5m. So that's all I needed to have for part A. For part B, I want to determine the force exerted on P by Q is being what I'm told about, and I want to, in terms of M, find the mass of box P. So it can be quite useful for these parts of the question if we consider adding in some light and extensible strings so we can think about all the forces a bit more clearly. So we've got P. If we add in a light and extensible string between P and Q, this is my Q. And again, I can put a light and extensible string between Q and the lift floor. And now we can think about all the forces a little bit more clearly, and it makes the diagram there. And as you know, this doesn't affect what's going on. So if I think about the forces that would be happening in here, this are my forces that are going to be on that string. I know that the weight of P is going to be Pg, the weight of Q would be Qg, and the force of the tension that's been pulled up on the lift is 42 mg over 5. So those are my forces, and I obviously had mg as the lift just for completeness. Now what they've told me is that the force exerted on P by Q, so that's this force here is 14 mg over 5. So they've told me that this force is 14 mg over 5. So I can add that to the diagram. And now what I'm interested in is P only. So I'm only interested in this bit here of what's happening to P only. And because I've now got those forces on nice and clearly, it allows me to think about what I'm doing. So if I'm considering P only, we know that I'm still moving upwards. So let's apply Newton's law, F equals ma. We're moving upwards, so the force that's going upwards is that 14 mg over 5. That's the force being exerted on P by Q. We're taking away the force acting downwards, which is the weight of P. and that's equal to the mass of P times the acceleration, which is still 2g over 5. So again, cancelling g all the way through and multiplying by 5, I've got 14m minus 5p equals 2p. So that gives me 7p equals 14m and p equal to 2m kilograms.